Hello and thank you for watching my video, and today we will be talking about chapter 9, Access Control List Part 1. This chapter is part of the semester 2 Routing and Switching by me, Astrid Krasniqi. Okay, on this chapter we will talk about using access control list to secure networks, TCP conversations, then we'll move on to port numbers, how access control lists work, types of Cisco ACLs, numbering and naming ACLs, ACL Wildcard Mask, Wildcard Mask examples, Wildcard Mask keywords, and then we talk about general guidelines for creating access control list and where to place ACLs. Then I'll do a demonstration on a standard access control list. Okay, administrators use access control lists to stop traffic or permit only specified traffic while stopping all other traffic on their networks. An ACL is a sequential list of permit or deny statements that apply to addresses or upper layer protocol. ACLs enables you to control traffic into and out of your network. The control can be as simple as permitting or denying a network host or address. So we use access control list to stop or allow specific traffic to our network. Now this list is statements. So once the router reads the list, access control list, reads one statement at a time. So it's a list of statements. So when there's a match, the router will not continue reading the rest of the statements or the rest of the list. Okay, if you remember the TCP conversation, reliable protocol, yeah, TCP is a reliable protocol. Now TCP provides a connection-oriented reliable byte stream service. The term connection-oriented means that the two applications using TCP must establish a TCP connection with each other before they can exchange data. TCP is a full duplex protocol, meaning that each TCP connection supports a pair of byte streams, each stream flowing in one direction. And TCP packets are marked with the flags that denote their purpose. So one flag we have a SYN, which is a start, synchronize the session. Then ACK is acknowledgement that an expected packet was received. And then we have a FIN, or finishes the session. So three different flags on TCP conversation. Okay, here we have a client and a server. They're going to have a TCP conversation with each other. So it's the client that starts the communication and says, let's talk. This is a TCP SYN packet or synchronization packet. Then their server will reply, should say, yep, sure, let's talk. But this is going to be a SYN packet as well. So it's a synchronization start from the server plus acknowledgement packet from the other packet that started from the client. Then the client sends a great, we have a communication or connection. This is again a TCP acknowledgement packet. So this is a three-way handshake on TCP conversation. Then the client is a normal packet. I need some data. I need you to send me some data. This is a TCP data segment. Thanks, I received your request, and this is again TCP acknowledgement packet. Here's the data that you wanted, TCP data segment. Then the client will reply saying acknowledge for that packet. And then the server will say, okay, I'm finished, TCP FIN acknowledgement packet. And then the client will reply with a FIN packet as well. So that was the TCP conversation, three-way communication. Now we talk about port numbers. So if you remember, the port numbers are divided on port groups. So we have well-known common ports. Do you remember the ports on the well-known group? So we have from 0 to 1023. All those ports are well known. So we have, for example, for HTTP, FTP, SMTP, POP3 and so on, these port numbers. Then we have registered ports. Registered ports are from 1024 to 49151. The registered ports are a different port group to well known. Then we have a private or dynamic ports, and this is 49,152 to 65,535. Well-known TCP ports, we have some ports here, for example FTP. Remember what was the port for FTP? So it's 20 and 21. Then Telnet 23, SMTP 25, HTTP 80, and POP3 110. These are only few port numbers that you really need to know for the Cisco CCNA exam and for the future job perspective. Well-known UDP ports, TFTP 69 and UDP port 520. Do you remember what that was? If you do, great. It's RIP. Packet filtering. A router acts as a packet filter when it forwards or denies packets according to filtering rules. As a layer 3 device, a packet filtering router uses rules to determine whether to permit or deny traffic based on the source and destination IP address. So we're permitting or denying traffic based on the source and destination IP address, source and destination port number, and the protocol, what protocol the packet is using. These rules are defined using access control list or ACLs. So on the packet filtering, the packet comes in, we look at the rules. If it's allowed, we let it go through. Well, the router does. Then another packet comes in. If it's denied, the router will not let it pass, will destroy it. How ACL works. Now here we have a inbound ACLs. Inbound ACLs is as they coming in to the router. These ACLs, our packets are processed before they are routed to the outbound interface. An inbound ACL is efficient because it saves the overhead of routing lookups if the packet is discarded. So if the packet is discarded, might as well just do it before it enters the router. Then we have the outbound ACLs. Outbound ACLs are routed to the outbound interface and then they are processed through the outbound ACLs. So inbound packets are routed to the outbound interface and then they are processed through the outbound ACLs. The last statement of ACL is always implicit deny. You have to remember that. That's why it's in bold here. You really have to remember this. This statement, it's always, as soon as you create an access control list, it will be there. It will be hidden, you can't see it, but it's there. This statement is automatically inserted at the end of each ACL. The implicit deny blocks all traffic. Because of this implicit deny, an ACL that does not have at least one permit statement will block all traffic. So don't go out there and configure the blocking here and blocking that and don't have any permit statement. You have to have one permit statement or you deny everything. Types of Cisco ACLs. First of all, we have standard ACL. Standard ACL, for example, goes access-list, then the number, then permit or deny, and then the source address with a wildcard mask. Standard ACL allows you to permit or deny traffic from the source IP address. So it looks only at the source IP address. The destination of the packet and the ports involved do not matter on the standard list, only the source. Because of the implied deny any at the end, all of the traffic is blocked with this ACL. So it's hidden deny any at the end, implicit deny. Standard ACLs are created in global configuration mode. Then we have extended ACL. So access-list and then the extended range number, permit or deny, then the protocol, in this case TCP, then the source address with the source wildcard mask, then the destination address, which is any on this case, that's the destination address, equal with 80. So we have a protocol, source, destination, and a port number. So extended ACLs filters IP packets based on the several attributes. For example, source and destination IP address. This one, that's the source. Any, that was destination. Source and destination TCP UDP ports. We have a port here, that's for destination port. If it was a source port, we'll put it here. And protocol type. What protocol type? IP, ICMP, UDP, TCP, and other. Using numbered ACL is an effective method for determining ACL type in smaller networks. So if you have very small networks and you're only going to have 3 or 4 access lists, then numbered is fine. But if you have a very big or large access control list, then numbered is not good. You have to name them, because they're not going to make sense what access list is meant to be doing. Access list 1 and access list 2 and 3, what they're meant to do. So it's best to name them. So standard access control list, we have from 1 to 99 and 1300 to 1999. Extended IP access list, 100 to 199 and 2000 to 2699. Now, this is very easy. 1 to 99 standard, 100 to 199 extended. Okay, that's great. But when it comes to the job interview or test or something, they're not going to ask you these. They're going to ask you these. So you better remember them. 1300, 1999. 2000, 2699. Extended access list. Now, numbers do not inform you the purpose of access control list. For this reason, starting with the Cisco iOS release 11.2, you can use now named to identify Cisco ACLs. You assign a name by providing the name of the ACL. So name can contain alphanumeric characters. It is suggested that a name be written in capital letters. Names cannot contain spaces or punctuation and must begin with a letter. You can add or delete entries within the ACLs. Okay, now we're going to talk about wildcard mask. It's very, very, very important topic. You have to understand, if you want to be good with access control list, you really need to know 100% pretty much what wildcard mask they're meant to do. ACL wildcard masks. Wildcard masks use the following rules to match binary ones and zeros. Wildcard mask bit 0 matches the corresponding bit value in the address. Wildcard mask bit 1 ignores the corresponding bit value in the address. So 0 is a match, 1 is ignore. Okay, we're going to have some examples here for you to understand wildcard masks. So we remember 0 bit means match something, 1 means ignore. So if you have 192 in decimal, the first octet, we represent that in binary, like 11000000. Then if you want to match these bits, if we want to match all the bits, then we write 00000 in all of them. And then in binary or in decimal, we represent that with 0. If we take the second octet, 168, we write it down in binary. If we want to match again all the bits on the second octet, again we'll write every bit is a 0. It means match all the bits. And that will be represented in decimal as 0. We take the third octet, 10. I'll write it down in binary. If I want to match all the bits on that octet, again I'll write all zeros. And in binary again will be 0. Then the fourth octet, 1. Now on this octet we want to ignore. We don't care what bits are there. So we'll write 1111. Now because we are writing 1111, we are saying we ignore these bits. These bits, they could be 1 or 0. We don't care. So that will be 255. So match 0, match 168, match 10, and ignore the last octet. Could be any number. So if a packet comes in now with the address 192.168.10.5, this will be a match because 0 matches, 192 matches, 168 matches, 10 matches. 5 here doesn't have to match because we said ignore. If we wanted to match, we would put all zeros here, but no, we ignored. So that will be a match. If another packet comes in with address 192.168.10.217, that will be a match as well, because everything, all 3 octets are matching, the last octet is being ignored, so it's a match. And the third packet comes in with address 192.168.10.133. Good guess? Yeah, it's a match. If a packet comes in Now the red packet, definitely not a match. 192, that's a match. 168, it's a match. But here we have 20. So third octet we match in 0. It should be 10. So in this case it's 20. So we're not matching. There's not a match. Okay. So in this wildcard mask, with this address, there was three packets, there was a match, and this packet, no match. Okay, let's take another example. Remember, the match, we put 0, ignore, put 1. 172. If you represent that in binary, it will be 10, 10, 1100. If we want again to match all these bits, all the bits, then we put zeros. And that will be 0 in decimal. The second octet, again, 16, match, all zeros, it will become 0. And the third octet, 130, in binary, and we match every bit on that, and become 0. Fourth octet, we ignore that. Just gotta say, this is not always the case. Whatever you want to match and whatever you want to ignore, you have to just place 0 for a match, 1 for ignore. So now we can have 4 packets again. One packet comes in with 172, 16, 130, 15. 172, there's a match. 16 matches. 130 matches. 15, we ignore it. So this is a match. Again, the next packet, it's a match. Third packet, it's a match. The fourth packet, because it's 192, already there's no match. So right away, no match. Okay, we'll take another example. Example 3. Remember that match is a 0, ignore, it's 1. So in this case we have 10. We represent that binary, we want to match every bit, and it will be 0. Now second octet is 10 again. Now this octet we want to ignore. We don't have to match, like it's not like subnet mask where the bits of 1s and 0s, they have to be continuous. Here we can mix and match bits and 0s and 1s as we want. So here we want to ignore this octet. Because we want to ignore this octet, it will be 255. Third octet is 0. But this octet we want to match. Now we put zeros. And that will be 0. At the fourth octet, it's 1. We want to ignore this octet. So we put all ones. So now the subnet mask will become 0.255.0.255. If a packet comes in 10, 16, 0, 200, it's a match, because 10, there's a match. The second octet we ignore in it. Third octet we are matching, so it's a match. If another packet comes in 10, 200, 0, 151, the second and fourth octet we ignore it. So they could be any numbers between 0 and 255. Just the first octet and third octet, there's a match. That's a match. That's what we care for. And the third packet, it's a match. And the red packet, here is not a match. Can you think and identify why there's not a match? Because here, the third octet, it's 1. So all the bits, there should be 0. So it should be 0 to be a match. But because it's 1, it's not a match. Calculating wildcard masks can be challenging. One shortcut method is to subtract the subnet mask from all 255s. Now this is for CCNA students. When you start from beginning, it can be very challenging, all these bits of 0s and 1s. So the easy way to find out what's the network wildcard mask is to subtract from 255s. So for example, we put 255, 255, 255, 255 on the top. That's binary representation. We take off our subnet mask, which in this case is 255, 255, 255, 0. So 255 minus 255, 0, 0, 0. And this one, 255 minus 0, will be 255. So our wildcard mask will be 0, 0, 0, 255. Okay, take another example. We put all 255s in the top. Take away our subnet mask. In this case is 255, 255, 240.0. Then our wildcard mask will be 0, 0, 15, 255. So we take 255 minus 240 is 15. 255 minus 0 is 255. And example 6, we put all 255s in the top, and that's our subnet mask. 255, 255, 255, 252. What do you think our wildcard mask is going to be? If you guessed it right, well done. 0, 0, 0, 3. Okay. Well, wildcard mask keywords. So example is 1. How to use the any option to substitute 000 for the IP address with the wildcard mask of 255s. So if you look at this wildcard mask and this address, it means 0, 0, 0, 0. Don't care the second octet, don't care the third, don't care about the fourth. So we really don't care anything, any of these. It could be any numbers. It could be 1, 2, 3, 4, 5, 6, 7, 8. Whatever numbers are here, we don't care. We're ignoring all of them. So if that's the case, then anything is matching. Well, if you're matching anything, you don't need to type all this because we are a bit lazy. So you can just substitute with the word any. Access list 10, standard. Permit any. Okay, now we have to use a host option to substitute the wildcard mask. So for example, access list 10, permit. This host 192.168.10.10. We match in the first, we are matching the second, we are matching the third, we are matching the fourth. So we want to match only this IP address. If we're matching only this IP address, then we can write down host on the front of the IP address. We don't have to write down the zeros. We can, it's not wrong, it's just the host makes more sense. Put host in front, then the IP address. General guidelines for creating ACLs. There is 3 P's when you think about ACLs. One access list per protocol. So whatever protocol you're using, IP, IPX, Apple, whatever, you have one access list per protocol. To control the traffic flow on the interface, an ACL must be defined for each protocol enabled on the interface. So if you're running IP and IPX, you have 2 access lists you're able to have. One ACL per direction. So one could be inbound and one could be outbound. One ACL per direction. And one ACL per interface. ACL controls traffic for an interface, for example, gigabit Ethernet 00. So if you have one interface, if we have this gigabit Ethernet and we have IP and IPX running, how many access lists can we have on this interface? Well, think about it. We can have one per interface. So, okay, and we can have one per protocol. So we have 2 protocols, IP and IPX, and we can have per direction. So we can have incoming and outgoing. So which means 1 per IP, 1 per IPX incoming, 1 per IP, 1 per IPX outgoing. So 4 access lists in total. Where to place access list? You should try and place the access list at where it has the greatest impact or efficiency. Standard ACLs, right? We have an example I have here. Router A has got neighbor with router B. Router B has got neighbors with router C and D. C has got network 192.168.100.4/24. And D has got network 172.16.1.0/24. Now, this is standard access list. A packet comes in that has source IP address 10.1.1.1, destination IP address 192.168.100.1. So it's coming from the source 10 and it's trying to go to this network here. Now, because standard access control lists do not specify the destination address, place them as close to the destination as possible. Because standard access list looks at the source only. And if it's looking at the source only, now you only reach the destination, you're going to put it closest to the destination. If you put it here, this packet will be blocked here right away. So because it looks at the source, it's blocked, boom. But maybe the destination was here, to go here, the packet. So you just blocked the wrong packet. So because it looks at the source, you have to put it as close to the destination, which is, on this case, is here. That's closest to the destination. Extended ACLs, on the other hand, you have to put them as close to the source as possible, because they look at the source IP address, they look at the destination IP address, the protocol, the port number, everything about the packet they know. So you can put it right away at the source, so you don't waste the other router's processing power. For example, we have a task to deny network 10.1.1.0 for reaching network 192.168.100.0. So you don't want the network 10 to reach this network. Now there's two packets. One, it's coming with the source that we want to deny to destination that we want to deny, 192.168.100.1, this destination. And there's another packet comes in with the same source, but destination is here, the router D. Now, if you block them, if you apply access list here or here, the both packets will be dropped. The reason is because it's only the source. It will read only the source, not the destination. Well, not where is it going. So, for great effect, you have to put it as close to the destination as possible. So, entering criteria. You should have the most frequently used ACLs entry at the top of the list. If no matches are found, when the router reaches the end, the traffic is denied, because remember, we have that hidden command, implied implicit deny. So standard ACL logic. ACLs, for example, access list deny 192.168.10.1. Access list permit 192.168.10.0. Now I'm going to use a paint so we can go through this, the logic. Okay, I'll put them in the paint here. So you have to put more specific statements at the top here, because when it reads, if there's a match, it doesn't continue reading the rest of the statements. For example, here it says access list to deny this host. There should be a host there. All zeros in the end. All 0, 0, 0, 0. Right. Now, if it reads this statement, it says, okay, well, this host deny. That's fine. If it's not going to continue to read the rest of the statement, if there's a match. But if you accidentally put this statement underneath this statement, now this host will not be denied, because this is a match. So if I move here these numbers, this is the wildcard mask underneath here. 0 means match, 0 here match, 0 here match, 255 means ignore. So with this statement, this host is going to be a match, so it's going to be permitted. And after it's permitted, it's never going to go and read the second statement. So more specific statement, they have to be at the top. So in this case, for example, standard access list to deny this host, then permit this host. Then 192 deny the rest. So we're going to deny, on this case, 9, 10, 1, 2, 3, 4. We did permit 10 only. So this says deny this host, allow 192.168.10.0, that network, but deny everything else, 192.168.0.0 without wildcard mask. And it's less specific now. Access list to permit 192.0.0.0 with a wildcard mask of 0.255.255.255. So the more general match criteria at the end of the access list. In here we have the most deny any. It's hidden. Applying standard ACLs to the interface. So after standard access list is configured, it's not doing anything. It's a global configuration command, doesn't have any effect. So you have to link it to the interface by using the command IP access group. You go to the interface, IP access group, then access list number or the name, and then in or out. For example, router config -if, if we are in the interface configuration, IP access group 1 in for incoming. To remove an ACLs from the interface, first enter the no IP access group command on the interface, and then enter the global no access list command to remove the entire ACL. To remove the ACLs, the global configuration command is no access list command. Like that. The remark keyword is used for documenting and making access list a greater deal easier to understand. Imagine if I create an access list here, access list 5 deny 192.168.100.1, all zeros, host. 6 months down the line, you come in, you don't know what I was doing, what I was trying to accomplish. So the best thing is to write a remark. So access list 1 remark, permit only John's workstation. Yeah, okay. If anybody comes 1 year or 10 years later, knows what this access list was trying to do, to accomplish. So here, for example, you go to the interface closest to the destination, access list 21 deny host 10.1.1.1, access list 21 permit any, you have to permit everything else, and then go to the interface and IP access group 21 out, because the packet as they going out from this interface, you are denying them, not when they come in, or as they're going out. Editing standard numbered ACLs. For example, ACL 1 access list 1 deny host that host. Access list 1 permit 192.168.0.0.0.255.255. Now you made a mistake. It wasn't meant to be 99. It was meant to be something else. So first you say show access list to see what it is. Okay. Now I can find that it got like a statement. These are the access list state sequence I mean. So we have a sequence 10 and sequence 20. So sequence 20 we have a 10 deny 192.168.10.99. We don't want that. So we can go to that access list, IP access list standard 1, and then no 10. That's it. We are just denying, we are deleted the sequence 10, and we add the new sequence. Again, could be 10. We could write different number, 9, 8, 7, whatever, 15. 10 deny host 192.168.10.10. Now we can edit named access control list. It's a bit more easy with a named access control list. So show access list 1. We can see that's our statements. Now adding a line to named access control list, we go to that IP access list standard and then the named whatever we used. 15 deny, so we put the sequence in between, for example 10 and 15. Okay, these two access lists are not the same, but you see the point. So we just add the like a sequence number in front, and when we do show access list 1, okay, these numbers and this is not correct. Now we will see sequence 15 is gonna be inserted in the middle. Okay, now I will do a demonstration onto configuring a standard access control list. Now we're going to create the standard access list from scratch. We're going to have a server here, a router, and I'm going to have two machines. So PC1 and PC2. I just got PC1 here, PC2. Going to get rid of that PC0, and I'm going to have a switch here as well. Okay, so let me delete this PC0. No, I don't want to delete the switch. Delete the PC0. Okay, so we have PC1, PC2, switch, router, and a server. I'm going to connect PC1 straight through cable with the switch. Doesn't matter the ports, we're not doing switching. And PC2 with the switch. Then I'm going to connect the switch PC3, FA03 with the FA00 here. And then I'll do a crossover cable, the server with a fast Ethernet 01. Okay, so let me just write down FA01 here, and on this side, so we remember FA00. Now, this network here, we're gonna use. It's gonna have IP address 10.1.1.1 /24. Gonna move these devices a little bit up so I can write down the IP addresses here. This PC is gonna have say 100 4/24, and this PC here is gonna be 200. Okay. The server on this side, we're gonna have 172.16.1.254 4/24. and the router is going to have 1 IP address on the fast Ethernet 01 172.16.11/24. Okay, now I'm going to do the configuration, but I'm going to go fast on this because you should already know how to configure these, how to set up the configuration. Okay, first of all, PC1. So I'm going to do it very quickly. Go to config on desktop, IP configuration 10.1.1.100, and the subnet mask /24, and the gateway is going to be all ones. Oh, too many ones, too many dots. Done. Let's do PC2 now. PC2 is going to be desktop 10.1.1.200 /24 10.1.1.1. Okay, done. Server, gonna go to desktop, IP configuration 172.16.1.254 255.255.255.0, and the gateway 172.16.1.1. Okay, done. Now I'm gonna go to the router, configuration of the router, the startup configuration. So go to CLI, no here, enable. Now I'm gonna do, I like to do the configuration, my configuration on the notepad, and then I can just copy and paste it. So I'm gonna type enable config t, and then after that I'll do like a housekeeping configuration commands. You should do them all the time, get used to it. So enable secret, enable password class or Cisco, enable secret class, no IP domain lookup, service password encryption, and the hostname all one. Let's say line console 0 password Cisco, login, exec timeout 00, login sync, then line pty 024 password Cisco, login, exit, and I'll do a ban as well, MOTD, authorized users only. Okay, then I'll do end and copy running to startup. Okay, highlight all of this, right click in the router and paste it. Okay, just search if there's any spelling mistake. Ooh, no spelling mistake. So click enter, press enter. We're done. The next command, I'm gonna do the IP configuration. So it's gonna be, first of all, interface FA00, IP address 10.1.1.1 via the /24, no shutdown. Then interface FA01, IP address 172.16.11/24, no shutdown. Okay, I'll just do a config T here and copy and paste all that in my router. Okay, and show IP interface brief. Yep, both interfaces are up, it's working. So if I go to my network here, I should see everything is green. Well, this switch is spanning tree, so it's gonna come out green in 50 seconds. Okay, so I should be able to ping pretty much everything. So PC1 should be able to ping server and PC2. So let's check. Go to PC1, ping PC2, so 10.1.1.200. Yeah, I have a reply. Excellent. Ping 172.16.1.254. Let's see for the server. I have a reply for that as well. Okay, I can test PC2 as well, just very quickly. So ping 172.16.1.254. I'm not gonna ping the PC because I already had a reply in PC1. So everybody is connected to each other. So now we want to create an access control list to deny PC1 accessing the server, but allow PC2 to access the server. Now, either websites or either ping-in, deny everything. So I can do 172.16.1.254. Yep, I have a web communication as well. Okay, now to do that, I'm going to write down an access control list. This one is going to be the standard. So access list. I can choose a number here between 1 and 99. Well, let's choose 55. We can say permit 10.1.1.200. I can put all zeros here at the back, or because this is a host, I want to permit this host only, I can put host here. And that's it. This interface, this access list will be pretty good. Just for the exercise, just so we can see it, I want to deny as well. So write down the statement here. The reason why I say this access list will work, because there's a hidden statement underneath here. That's access list, it will come up 55, deny any. This statement is hidden, but it's there. So access list 55, deny host 10.1.100. So PC1 will not be able to communicate with the server or with anything after this port. Okay, now I'm going to permit everything else. So access list 55, permit any. Now with this statement, permit any, this statement is it's redundant really. I can delete it and it will achieve the same thing. I can just, and it's exactly the same thing. Just so we can see it, I have it there. Now and then underneath that, I'm going to write it down again. Now don't forget that. There's access list 55, deny any. Okay? Don't forget it's there. Now this access list is not going to do anything because it's a global configuration command. It doesn't have effect at all. If you don't, you have to link it somewhere. So we're going to link it. Where do you think we're going to link it? Which interface? This one or this one? Now remember, this is a standard access list. We're looking at only the source, not the destination, just the source. And with the source, we have to link it closest to the destination. So it has to be linked on that interface going out. So I have to go to interface FA01 and say IP access group 55 out, because the packets are going out. As they're going that way, they are going out. If you put in here, for example, that will be wrong, because the source will be 172.16.1.254. It will always be permitted. So the source, it will be out. It will be correct. So the router will look at the source only. Okay, so I'm going to copy this statement and paste into the router. So config T here, paste it to the router. Okay, do show run to see what's happening with our router. So we have access group 55 out on the FA01. We have access list 55. We denying something. They're on host. We allowing everything else. Okay, the commands as well to see the access list is show access list. So standard IP access list 55. We denying this host. We permitting this host, and then we permitting everything else. Okay, so I'll go to PC2 and try and do the ping again. So ping, yep, I got a reply. I'm gonna go to the router and just repeat the same command again. But now look, there's four matches. There has been 4 replies. So it's 4 matches. If I go to PC2 again and try and access a web page on that server, 172.16.1.254. Yep, it's fine. So if I go to the router, repeat the same command again. Yep, there's some more matches on this host. Now I'm going to do it from PC1. Before I could ping it. So let me try again. Ping 172.16.1.254. Now I got a reply, but this reply is from my gateway, and it says destination host unreachable. So I'll go to my router and repeat the command, show access list. Now from this host it says there has been 4 matches to deny. I'll try and access it through the web browser. So 172.16.1.254. Hit enter. It's gonna be request timeout. Yep, it's not working. Go to this router. Show access list again. Yeah, I can see there's some more matches. 16 matches has happened. So there's quite a lot of matches now happening from PC2. Oh, sorry, PC1. PC2 is permitted. So this is a basic standard access control list configured. One more, I want to show you how to configure access control list on VTY lines if you are accessing this router to telnet. So there, I'm gonna create a named access control list. Okay, now I'm gonna create the named access control list. So I'll open my notepad again. For this, to create a named access control list, the command that you start with is not access list. You have to add IP access list. And then choose whether you want standard or extended. In this case, we want standard. And then we write a name. Now access list, they said that we can't start with a space. It's better, it's recommended to use capital letters. So that's what we'll do. No telnet for PC2. PC2. Here, IP access is standard, no telnet for PC2. Okay, after we hit enter, then we can write a remark if we want to tell what we did here. We didn't want PC2 to have a telnet and so on. So we start with you can start with a sequence, like sequence 10. Sequence 10 will say deny something. So deny host 10.1.1.200. Sequence 20 will say permit host 10.1.1.100. Yeah, that will be good. Again, the access list is made in the global configuration mode, so we have to link in somewhere. This time we want to link it to the VTY line. So line VTY 024 IP access class no telnet. So I'm just going to copy this, copy and paste. Oh, where did I paste it? Here, paste in. Okay, now again on the telnet is class, access class. On the interface is access group. That's why I wanted to show you this. So I'm gonna paste this to my router. Config T. Okay. No spelling mistake. So show run. So access list standard, no telnet for PC2. Denying hosts PC2. We align PC1. And oh, sorry, we have I made a mistake here. So because that's for IPv6, so no IP access class, and I'll just write access class no telnet. So I'm gonna paste this, copy this again, and then in. Okay, I can copy everything. Let me just copy this bit. config T, right click, paste. See, that's why it's great if you do it in Notepad. Like, you can just go back and copy and paste stuff. So do short run. Okay, here now we have access class, no telnet for PC2. We didn't test it. Let me go and test it first, and then I'll show you first that it's actually working, and then we can deny it. Okay, so PC2, I go and type telnet 10.1.1.1, the gateway. Yep, I see the password, which means I'm in there. So Cisco enable class, I'm inside. Exit. PC1 telnet 192, oh sorry, 10.1.1.1. Yep, password, I can see it. Right, all PCs they can telnet, but what we want with our access list, we don't want PC2 to be able to telnet. So copy that to my router, paste it. Okay, now that should be having effect. PC1 should be fine still. Yep, as soon as I see password, I know I'm inside. Now PC2 should not. Alright. Ooh, says connection refused by remote host, which means we are denied by that. Okay, thank you for watching. This has been Asri Krasniqi. Hopefully I'll see you in the next videos. Make sure you're watching part 2, extended access control list. Bye.